Lesson 8.10 is on nonlinear systems. In this lesson, we'll solve systems of equations in two variables in which one equation is linear and the other is quadratic. So we'll have one equation that's a straight line and the other one will be a parabola, so a curve. So why learn this? You can solve a nonlinear system to find how long it takes for two objects to reach the same height. Recall that a system of linear equations is a set of two or more linear equations. A solution of a system is an ordered pair that satisfies each equation in the system. Points where the graphs of the equations intersect represent solutions of the system. A nonlinear system of equations is a system in which at least one of the equations is nonlinear. For example, a system that contains one quadratic equation and one linear equation is a nonlinear system. So a system made up of a linear equation, so a straight line, and a quadratic equation, a parabola, can have no solution, one solution, or two solutions. So no solutions means they're not going to intersect at all. One solution, the vertex or one point of the parabola intersects the linear equation, and two solutions if the parabola crosses this linear equation twice. So in this lesson, we'll look at different strategies to help us solve these systems. So first, we're going to start by looking at graphing. Graphing is one method to help us see what the solution is. So y equals x squared minus 2x minus 3, that's our quadratic, and then y equals negative x minus 1. So we're going to graph both of them and then find the points where the two graphs intersect. Remember, a quadratic function has the form y equals ax squared plus bx plus c. To graph a quadratic function, start by using x equals negative b over 2a. That will help you find your axis of symmetry. Then you'll substitute that x value in to get your vertex. You can also identify your y-intercept and two additional points, reflect them to form your parabola. So here, x equals negative b, so negative and then negative 2 over 2 times a, so 2 times 1. So x equals negative 2 times negative 2 will give me a positive 2, or sorry, negative times a negative 2 will give me a positive 2. 2 times 1 is 2. So x equals 1. And then to get our vertex, we would substitute 1 in. So y equals 1 squared minus 2 times 1 minus 3. 1 squared is 1. 2 times 1 is 2. So 1 minus 2 minus 3 will give us negative 4. So our vertex here is 1, negative 4. So my axis of symmetry is at 1. So I'm going to sketch that in there. My vertex is at 1, negative 4. So write 1, down 4. And then I can also identify my intercept. That's my C term. So my intercept is going to be 0, negative 3. So right here. So since my intercept is to the left of the parabola, I'm going to pick two x values to the left. So starting here, I already used 1, 0, so I'm going to do negative 1 and negative 2 to get two additional points. So x equals negative 1. So I'm going to have y equals negative 1 squared minus 2 times negative 1 minus 3. Negative 1 squared is 1. Negative 2 times negative 1 will give me a positive 2, and then minus 3. That will give me 0. So this coordinate will be negative 1, 0. So left 1, and then I'm not going up or down at all. And then I'll do one more, negative 2. So I'll have y equals negative 2 squared minus 2 times negative 2 minus 3. Negative 2 squared is 4. Negative 2 times negative 2 gives me 4, so plus 4, and then minus 3. This simplifies to 5. So another coordinate will be negative 2, 5. So left 2, up 1, 2, 3, 4, 5. And then everything I have on the left here, I can reflect to the right. It's just the same distance from the axis of symmetry. So this guy is 1, so 1 away over here, 2 away on the right side, 3 away on the right side. So I'm going to go ahead and connect these to form my parabola. So that's my quadratic equation. If I need to later on, I can extend to negative 3 to get one more point if my equation is kind of up here to find where they intersect. But if I don't need to, you don't have to. So the second thing is I'm going to graph my linear equation, y equals negative x minus 1. So my intercept is 0, negative 1. And then my slope is negative 1. So negative 1 over 1, or you can write that as 1 over negative 1 till you do your rise over run. So I'm going to graph my intercept first. So 0, negative 1, right here. And then I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And then keep on going. And the other direction's up 1, left 1. So then from here, I'm going to go ahead and connect my dots. Now I recommend using a straight edge to connect them. So that is my linear equation. So I have my parabola, my quadratic, and then my straight line, which is my linear equation. So you see that they intersect here and here. So I just need to name those points. So this is negative 1, 0. So that's one solution. And the other coordinate, this guy is 2, negative 3. So those are the two solutions to this system. So now there's a check it out for you to do. There's a quadratic and a linear equation for you to graph and identify the solution. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So I'm going to start by looking at my quadratic equation. So y equals x squared minus 4x plus 5. I'm going to identify that axis of symmetry. So x equals negative b. B is negative 4 over 2a, so 2 times 1. Negative times a negative is a positive, so I have positive 4 over 2, which gives me 2. And then to get my y value for my vertex, I'm going to substitute in the 2. So 2 squared minus 4 times 2 plus 5. 2 squared will give me 4. And then 4 times 2 is 8, so minus 8 and plus 5. That gives me a positive 1. So my vertex is 2, 1. So my axis of symmetry is at 2. And then my vertex is 2, 1. So right 2, up 1. So then I'm going to identify my intercept. My C value is 5. So when x is 0, y will be 5. So 0, 5, 1, 2, 3, 4, 5. So my intercept is to the left of my axis of symmetry, so I'm going to pick two other x values to the left. So we started at 2. I don't have a value on 1, so I'll substitute in x equals 1. And then we used 0 already, so my second value would be negative 1. So substituting in 1, y equals 1 squared minus 4 times 1 plus 5. 1 squared is 1. 4 times 1 is 4, so 1 minus 4 plus 5 will give me 2. So another ordered pair would be 1, 2. So right 1, up 2. And then I'm going to substitute in negative 1. So y equals negative 1 squared minus 4 times negative 1 plus 5. Negative 1 squared is 1. Negative 4 times negative 1 is a positive 4. And then plus 5, that will give me 10. So another coordinate is, I apologize, that was negative 1. I substitute negative 1. So negative 1, 10 is my other coordinate. Reflect everything to the right. And then connect them to form your parabola. Second equation, y equals x plus 1. I'm going to start at my intercept, which is 0, 1. So right here. And then my slope is 1, so 1 over 1, or I can think about that as negative 1 over negative 1 for your rise over 1. So up 1, right 1, up 1, right 1. Other direction is down 1, left 1. And then you can connect your dots once you get a good idea of what's going on. And there's your graph. So now you just need to set your solutions. They intersect right here. So I'm going to write down our solutions. This first point is 1, 2. So that's one coordinate. The second one is right here. So that's 4, and then we went up 5. So 4, 5. So that is solving systems by graphing. The second method we're going to talk about is using substitution. So solving a nonlinear system by substitution. Remember, substitution method is good to use when either equation is solved for a variable. So that means you take what the one equation equals, replace it for that variable in the second equation. So both of these are solved for y. So I can take what y equals and substitute it in to the other equation. So I'm going to take what y equals in my second equation, x plus 2, and replace that in my first equation. So this y will become x plus 2 equals 2x squared minus 3x plus 4. Now to solve this for quadratic equations, you want to write it in standard form. So get everything to one side. So I'm going to subtract x from both sides first. So I'm going to have 2 equals 2x squared. Negative 3x minus x is negative 4x plus 4. And then subtract 2. So we have 0 equals 2x squared minus 4x. 4 minus 2 is 2. So positive 2. Then from here, the first thing you always want to do when you're looking at quadratic equations is see if there's a GCF. And there is. 2, 4, and 2, I can pull out a 2. So I'm going to rewrite this. So I'm going to pull out a 2. So what's left is x squared minus 2x plus 1. Then from here you have options. And we talked about this in the last lesson. You can choose how you want to solve this. Always try to see if you can easily factor it. If not, you want to consider some other options, maybe completing the square, using the quadratic formula. Here, this can be factored. So this is going to be 0 equals 2, and I can do x minus 1 times the quantity x minus 1. Negative 1 times negative 1 is a positive 1, and then negative 1 plus negative 1 gives us that negative 2. This is actually a perfect square trinomial, so I could write this as 2 times the quantity x minus 1 squared. So this guy is only going to have one solution. So we're going to set our factor, x minus 1 equal to 0, and solve. So add 1 to both sides to get x equals 1. And then to get the y value that goes along with this, we can either use either equation and substitute in the x value. I'm just going to use the second one. So y equals x plus 2. So we're going to have y equals 1 plus 2. 1 plus 2 is 3. So our solution, putting that together and writing it as an ordered pair, is 1, 3. So now there is a check it out problem for you to do. You're going to solve the system by using substitution. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So I'm going to substitute negative 3x plus 4 in for y in my first equation. So negative 3x plus 4 equals 3x squared minus 3x plus 1. I'm going to add 3x to both sides. So we're going to get 4 equals 3x squared. This gives me 0, so I have plus 1. So the reason I'm doing this is to write it in standard form. So then I want to get 0 on this side, so I'm going to subtract 4 from both sides. 4 minus 4 is 0, So I get 3x squared. 1 minus 4 gives me negative 3. Then from here, the first thing you always do is look for a GCF. So I can pull out a 3. So I'm going to 0 equals 3 times the quantity x squared minus 1. X squared minus 1, we have a difference of perfect squares. So to factor this, I'm going to have 3 times x plus 1 and x minus 1. So for this one, we're going to have two solutions. So I'm going to set both of these equal to 0. So x plus 1 equals 0, x minus 1 equals 0. So subtract 1 to get x equals negative 1. Add 1 to get x equals positive 1. So then I have to substitute these in to one of my equations. I'm just going to use the second one. It's a little bit easier to solve a linear equation than a quadratic since you have to substitute in two terms, but you can always use that first one if you want. You will get the same answer, it just might take a little bit longer. So I'm going to do x equals negative 1 and x equals positive 1. So I'm going to use y equals negative 3x plus 4. So I'm going to have y equals negative 3 times negative 1 plus 4. Negative 3 times negative 1 is a positive 3. Plus 4 gives me 7. So the solution for x equals negative 1 is negative 1, 7. And then I have to do the same thing with positive 1. So I'm going to substitute it into the equation. Y equals negative 3x plus 4. So y equals negative 3 times 1 plus 4. Negative 3 times 1 is negative 3. And negative 3 plus 4 gives me 1. So the second solution is 1, 1. So now we're going to go ahead and look at example 3. We're going to solve a nonlinear system by elimination. Now for elimination, you want to look for a variable that has opposite signs. So when you add them, you could get 0. Or if they are the same sign, same coefficient, you would subtract. So here in A, I have negative y and a positive y. So I can add those two equations together, and that y term would be eliminated. So I'm going to line these up. So we're going to have 4x minus y equals 2. And this y will line up underneath. And then we have equals x squared plus 1. So they're opposite signs, so I'm going to add. Now, whatever's on the left side you'll add together, right side you'll add together. And if you have any like terms, you're going to combine them. So I'm going to have 4x on the left, negative y plus y gives me 0, equals, and over here, I'm going to have x squared, and then 2 plus 1 gives me 3. So now I'm going to rewrite this in standard form. So I'm going to subtract the 4x from both sides. So I'm going to get 0 equals x squared minus 4x plus 3. There's no GCF here, but this equation can be factored. So I'm going to rewrite it as x minus 3 times the quantity x minus 3 times x minus 1. Negative 3 times negative 1 will give me a positive 3, and then negative 3 plus negative 1 will give me the negative 4. So set these equal to 0. So add 3 to both sides to get x equals 3. Add 1 to both sides to get x equals 1. Then you want to substitute them into one of your equations and solve for y. Doesn't matter which equation you use. I'm going to use the second one because y is already solved for, so when I substitute in x, I can easily find y. You can use the first equation, though, if you want. So we're going to do x equals 3. So I'm going to have y equals 3 squared plus 1. 3 squared is 9. 9 plus 1 is 10. So 3, 10 is the first solution. And then I'm going to substitute in x equals 1. So I'll have y equals 1 squared plus 1. 1 squared is 1, and 1 plus 1 is 2. So my second solution is 1, 2. I have y equals x squared plus x minus 1, and 2x minus 3y equals 6. Now, these y terms are opposite signs, but they don't have the same coefficient. So when we talked about elimination before, when we were solving systems of linear equations, you want that coefficient to be the same. So you can multiply one equation to get those coefficients to be the same number. So I'm going to multiply this first equation by 3. So we're going to have 3y equals x squared, or 3x squared, I apologize. You're multiplying every term. So 3x squared plus 3x minus 3. Now this negative 3y and 3y, if I add them together, will become 0. So I'm going to have 2x minus 3y equals 6. So now I'm going to go ahead and add down. So I'm going to have 2x, the 3y plus negative 3y gives me 0, equals, and then over here on the right hand side, combine your like terms. So I'm going to have the 3x squared plus 3x. Negative 3 plus 6 gives me a positive 3. So then from here, I'm going to subtract 2x from both sides to write it in standard form. So I get 0 equals 3x squared. 3x minus 2x gives me 1x, and then I have plus 3. So here, 0 equals 3x squared plus x plus 3. There's no GCF. This one, I can't think of a way to factor it right away, so I would recommend using the quadratic formula. Remember, quadratic formula will always give you the answer. It just might take a little bit longer than factoring, but since I can't see a way to factor this, I'm going to jump right to the quadratic formula. So I'm going to have x equals negative b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4ac. So 4 times 3 times 3, all over 2a, so 2 times 3. So x equals negative 1, plus or minus, 1 squared is 1, minus 4 times 3 is 12, times 3 is 36, and then 2 times 3 is 6. So we have x equals negative 1, plus or minus. 1 minus 36 is negative 35, and then it's all over 6. Now, we cannot take the square root of negative 35. So this means there are no real solutions. Remember we talked about the discriminant in the last lesson? If it is a negative value, means no real solutions. You can't take the square root of a negative number. So for B, there's no real solutions to that system. So now there are 2 check it out problems for you to do. You're going to solve the systems via eliminations. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for A, negative y and a positive y, so I can add to eliminate that y term. So I'm going to rewrite them so my y's line up. So I'm going to have 2x, negative y plus y gives me 0, equals, over here I'm going to have x squared, and then 2 and plus negative 5 gives me negative 3, so minus 3. Write it in standard form, so subtract 2x from both sides. So I get 0 equals x squared minus 2x minus 3. For this one I can factor. I'm going to factor it as x minus 3 times the quantity x plus 1. Negative 3 times 1 will give me that negative 3. Negative 3 plus 1 gives me negative 2. Set your factors equal to 0. So I'm going to get x equals 3, and then I get x equals negative 1. Then I have to go and find the corresponding y value. So here we're going to substitute in x equals 3. So I'll have y equals 3 squared minus 5. 3 squared is 9. 9 minus 5 is 4. So we get the solution 3, 4. And then substituting in x equals negative 1. So y equals negative 1 squared minus 5. Negative 1 squared is 1. 1 minus 5 is negative 4. So we get the second solution as negative 1, negative 4. For b, y's are opposite signs, but I need to get that coefficient to be the same. So I'm going to multiply my first equation by 2. So I have 2y equals 2x squared minus 4x minus 10. So I'm going to have my second equation underneath, and I'm going to add down and combine my like terms. So the 2y and the minus 2y will give me 0. So I have 5x equals, over here, 2x squared minus 4x. Negative 10 plus 5 will give me negative 5. Then I'll subtract 5x from both sides to write it in standard form. So I get 0 equals 2x squared. Negative 4x minus 5x will give me negative 9x. And then I have minus 5. Here, I really can't see an easy way to factor this right off the bat, so I'm going to go ahead and use the quadratic formula. So x equals negative b, so negative 9 plus or minus the square root of b squared, so negative 9 squared minus 4ac all over 2a. So negative times a negative is positive, so positive 9 plus or minus the square root. Negative 9 squared is 81. Negative 4 times 2 is negative 8. Times negative 5 is a positive 40. And 2 times 2 is 4. So x equals 9 plus or minus the square root of 121 over 4. And the square root of 121 is 11, so we have plus or minus 11. So our two cases, we're going to have x equals 9 plus 11 divided by 4, and x equals 9 minus 11 divided by 4. So x is going to equal 5, and x will equal negative 1/2. So now I have to use my equations to go ahead and figure out the corresponding y value. You can use either equation, it doesn't matter which one. So we have x equals 5 and x equals negative 1/2. Or you could write this as negative 0.5. That might be easier for you when you're simplifying. I'm going to use the first equation, so y equals 5 squared minus 2 times 5 minus 5. So y here is going to equal 10. So your coordinate is 5, 10. And then for the second one, y equals negative 0.5 squared minus 2 times negative 0.5 minus 5. Sorry, I'm running out of room there. When you simplify, you get y equals negative 3.75. So your ordered pair is negative 0.5, negative 3.75. So now we're going to go ahead and look at example 4. So in example 4, it says an elevator is rising at a constant rate of 20 feet per second. Its height in feet after t seconds is given by h equals 20t. At the instant the elevator is at ground level, a ball is thrown upward with an initial velocity of 80 feet per second from ground level. The height in feet of the ball after t seconds is given by h equals negative 16t squared plus 80t. Find the time it takes for the ball and the elevator to reach the same height. So we have these two equations and we're going to solve the system. And you can use substitution here since they're both solved for h. You're going to take what h equals in the first equation and replace it for h in the second one. So you'll have negative 16t squared plus 80t equals 20t. Write it in standard form. Then factor out your GCF. The GCF here is negative 4t. So you'll have negative 4t times the quantity 4t minus 15. Set both your factors equal to 0 and solve. So we get t equals 0, and then we get t equals 3.75. So t equals 0 isn't our solution. That's just at 0 seconds. So they're both starting at the same height. But it takes 3.75 seconds for the ball and the elevator to reach the same height, so above ground level. So now there is a check it out problem for you to do. It says an elevator is rising at a constant rate of 8 feet per second. Its height in feet after t seconds is given by h equals 8t. At the instant the elevator is at ground level, a ball is dropped from a height of 120 feet. The height in feet of a ball after t seconds is given by h equals negative 16t squared plus 120. Find the time it takes for the ball and the elevator to reach the same height. So we have two equations, h equals 8t and h equals negative 16t squared plus 120. So we're going to solve this system by substitution. I'm going to substitute in this 8t for h in my second equation. So I have 8t equals negative 16t squared plus 120. Write it in standard form, so subtract 8t from both sides. So I get 0 equals negative 16t squared minus 8t plus 120. So we're going to get 0 equals, and here you want to see if you can factor out a GCF. Between negative 16, negative 8, and 120, you can factor out negative 8. And you're left with 2t squared plus t minus 15. And here we can factor this. So we'll have negative 8 times the quantity 2t minus 5 times the quantity t plus 3. From here, you can set both your factors equal to 0. So we're going to have 2t minus 5 equals 0, and t plus 3 equals 0. So I'm going to add 5 to both sides to get 2t equals 5. Divide by 2 to get t equals 2.5. Second equation, subtract t. T equals negative 3. We don't talk about time in negative terms, so negative 3 wouldn't make sense for this real world situation. So the solution is just going to be the 2.5 seconds. So it takes 2.5 seconds for the ball and the elevator to reach the same height.